All righty. Excellent. Well, again, happy to have everyone on this webinar. Again, good morning, good afternoon, wherever you may be in the world. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. Agentic AI is raising the bar for what modern database infrastructure needs to handle. It is not only higher throughput, it is also burstier, more variable workloads, more short-lived environments, and faster iteration cycles driven by agents that create demand spikes and operational churn. In this webinar, we're really excited to have PingCAP co-founder and CTO Ed Wang and product manager Leah Du to show you how TiDB is built to meet that reality for teams that need to move fast without inheriting enterprise level overhead. We'll walk through how TiDB helps reduce cost surprises, simplifies operations through a unified platform, and stays resilient as workload patterns shift. Now, here's a high level overview of what will be covered in today's session. So, Ed's going to start and he'll kick things off with a fast CTO level view of what's changed in the agentic AI landscape and why it matters now. From there, Leah will then introduce TiDB Cloud Essential and TiDBX with a simple mental model for newcomers, including the key architectural leap and how that maps directly to predictable latency, fast elasticity, scale to zero economics, and converged AI capabilities in one system. And then finally, Leah will spotlight how platforms and companies like Manus and Diffie validate the one database for agentic workloads pattern, which will be followed by a short demo. Now, before we get started, for everyone tuning in, please feel free to drop your questions directly into the chat window. We'll be sure to answer them during the Q&A portion at the end of the webinar. And with that, I'd like to get things kicked off with Ed. Ed, the floor is yours.
Okay, thank you, Brian, and hello, everyone. When we were planning this webinar, the original idea is just like a normal webinar, sharing the use case, sharing the product updates. But a couple days ago, I changed my mind. I think the most important thing of the in our areas is actually happening. So uh, I don't know if you got the same feeling like me for recent 2 or 3 months. The coding agent have a huge improvement in the not in the user experience and the quality and also I think that's the first time that this kind of like Cloud Code codex this kind of coding agent can actually creating some really complicated software with very few prompt. So I think at this moment, the only thing matter is how we can leverage this kind of tool and sharing, our experience, best practice to you guys. And I think that's that is why I want to use this as the opening and sharing my experience and some of my humble insights around the agentic coding. Okay, yeah. Before getting started, I will do a quick introduction. My name is Ad, co-founder and CTO of PingCAP and TiDB. Um, and I'm super proud I'm still an engineer writing code every day. I will introduce my recent life in the next couple of slides. Okay, so uh, let me start it with something slightly uncomfortable if you are an engineer because nowadays the only suggestion I would make, which is today you don't touch the code. You, today I'm serious. If you're still spending the time and your time writing and focusing on the code details, you are probably in the using this kind of tool in the wrong way. I got a bunch of cloud host subscription. I use Codex, Open Code, a lot of different. I spend like thousands of dollars per month on a subscription on different kind of the agent coding too. And also not to mention the extra usage cost. Um, and today I found that I not treat the coding agent like a tool. You know, most of people, most of the engineers today using Cloud Code or the Codex and maybe the Copilot as a tool to helping you to write the code. But to me, I found that recently I treat my agent like a team. So most of the time, actually spending on setting the collaboration platform, orchestration, and setting the different roles for different agent. But I don't take any look about the code they generated. So basically, I just define the direction. I review the architecture decision, and the agent will execute. So I think this is the mental model change that's really important. So I put it in the first page. So let's talk about some numbers. First, I think today, if you are heavily using the agentic coding tools like different kind of the only metric the only metrics that matter, which is the consumption, the token consumption. So yeah, I basically I take a look at my consumption. My normal day burns like 1 billion tokens per day. So that sounds crazy. Um, but compares to hiring the big engineering team, I think this token consumption it is not too expensive, right? Compares to the cost of the real engineer. So basically today, for example, when I'm designing some kind of projects like I'm redesigning TiDB storage abstraction. I now today maybe I didn't try only one solution. I launch multiple, agent to try multiple exploration paths. I build a platform so that allow the agent to try different approach in their own sandbox with a distributed file system. So different agents will make different assumption. Uh, and another group of agent act like architect, compares different outputs and made comments and pick the best of the different approach and explore further. So that is how I can, make this kind of level of the consumption. So I share this number. Only my purpose is that today, if you can, burn as many as tokens, that also can show how good you can handle this, all the coding agent and tools. Okay, so I will share you a real world example. Uh, for example, about 1 month ago, I started the new project in PingCAP, which is a new product line. I want to try to find the boundary of the how coding agent could do. So I set up I try to build a new database from ground up, which is Postgres compatible, and it is cloud native, distributed from scratch. Only one person, which is myself, 1 month, and and with all of my agent team. And 1 month later, after spending near 30 billion of tokens, I think I have already got the first prototype of this project. And you can see this is one of the test case of this database. It is very complicated, very comprehensive feature, and so it is not a toy. It is not a the early prototype. It is really close to the production level of the quality, and I will also launch this product in the near future. So this is, compares to if this kind of complicated project we want to build in the old day, then maybe like dozens of engineer working at least 1 year. But today I can easily build it in, you know, just myself with, you know, crazy amount of the tokens. It is happening. So yeah. And on the other hand, because you know in TiDB, we offer the cloud database offering, managed service on our platform. And we noticed a very interesting signal. Today, more than 80% of the newly created TiDB cluster is actually created by AI. And also, TiDB is an open source project. And we also found that today more than 80% of the new code, in TiDB's repo, it is actually written by the AI agent. And so it is happening. And okay, what's the magic sauce? And I will share, some of my best practice. I know there's a lot of different approach out there in the community, but my approach is, very simple. My philosophy is burn as many as token you can, and that's the my philosophy. So. The first thing is, the token consumption. It is just like magic, but how to burn this level of token? It is. I will share some magic sauce and how to do that in the next few slides. So the first thing is, um, you know just like I said, most of the time I not focus on talking to the agent. I focus on building the orchestration layer to make multiple agents to work together. Because if you just use the Cloud Code and the Codex, you will find that every time you talk to the coding agent, it doesn't have the knowledge about the project you are working on. And every time you want to build a new feature, you need to open a new session. So that means the context window, they this coding agent will not have the full picture of the or the overview of the project you are working on. If you are just want to build some simple application or some CRUD prototype, this is good enough. But when you are want to do something like compiler, browser, or the database I'm building, this level, this kind of complicated project, you cannot just using one shoot to finish. That means you need to focusing on the orchestration layer. Okay. And you know, if you want to build the orchestration layer like I do, I would say I suggest you to focus on, setting the put focus on setting the agent roles or the responsibility. Not you don't need to focus on specific task or the specific feature. Basically I spent a lot of time to define the team organization. It's like, hey, you guys are chief architect. You have this ABC background. You are the senior database engineer. You have a lot of knowledge about Postgres and a lot of ecosystem tools. You basically is writing. I actually wrote a lot of life story for the agents, and also you need to put a lot of time in the test platform so that the agent can verify their work and make sure they are on the right direction. So the test is really, really important. But you don't need to focus in the specific test. You need to focus on how to test and also the platform to make the testing easier. That's what you should focus on. So, and also different roles. In my practice, I don't share the context between different role. I will have some team memory or the team context for the all the members understand what is going on and what project they are working on. The knowledge, it is the common the memory. But I will not share the working context between different roles. For example, when the coder or the engineer agent write the code. And another set of agent will act like the tester or the verifier. That that that's why you don't want to share the context because when the coder understand the context of the tester, the sometimes they will cheat on the test. So that's why I want to, you know, make some isolation between the different agents. And yeah, in my development environment, I basically build GitHub for my agents so that they can submit the issue and write the design doc and to collaborate like a real engineering team. And I also create the social network for the agents so that they can talk to each other, discussing the ideas. Yeah, so this orchestration layer, how to measure the orchestration layer is good enough. My metrics is the longer the agent can work without any human interfere or the human interrupt will be better. So that means, for example, when you setting the goal and the agent team in your platform can run like 1 or 2 days without any human in the loop, that will be the a good try. Okay. And the second, magic sauce will be, um, I think you need to store everything. So if you want to build the agent team, the data will be very, very important. For example, uh, because I know a lot of you may focus on the model itself, but to me, and even I know some of my friends also want to use some data to fine tune the model. But that re I don't think the fine tune is a good practice because you know every couple months when the new model ship uh, it will beat the old model. So that means you when you are going to build some complicated project, you always need to use the best model. That means when the stronger model shipped, my strategy will always use the stronger model. But the key point is when you store everything, you will have a lot of lesson learned and the context and practice in your database, so that when you ship plug them with the stronger model, you don't need to restart the the project from scratch. So that is because we are a database company, so we we already have all the infrastructure, all the tools we need to help us to build the memory system for the agent. And we found that these patterns happen all the time recently. We found that a lot of our customer actually are using TiDB to store different kind of agent output and also the memory. So I think that is that will be a very important use case for the agent database like TiDB. Okay, all right. And also, in the traditional way of using the coding agent, we are always the pattern is like conversational. It's like human beings, human ask a question and or send the requirement, and the agent will, do the work. A couple minutes later, it, it will say, "Hey, it is finished. I'm waiting for the next instruction." But my approach is a little bit different. I don't want to, the agent to stop working because I think the agent should, work continuously, and I don't manually dispatching the task. So basically, I put my agents in the, you know, infinity loop. So and every 5 minutes it will go to the GitHub to find out the issue they will they will working on and automatically do the work so that in my practice, I use the raffle loop, and but don't just use the naive raffle loop. In our implementation, we have a lot of different events and trigger to make sure this loop can, continue iterate forever. But also you need to set some limitation and caps, so that you will not burn too much cost. Okay, because in my mind, the human being in this kind of agentic loop, I think human being will just be the reviewer. I don't want myself as the task dispatcher because when the agent they are going to wait my instruction or wait my task, that means myself will be the I will be the bottleneck. I don't want to be the bottleneck, right? So uh, that's why I think you need to design the mechanism that uh, the agent coding team will run autonomously and never stop. So. And the last but not the least, let's talk about the team, the engineering organization. I mean the human being, the human engineering team organization. What it will be looks like in the area of agents. My practice is, today the small team with unlimited infinity token capacity will perform better than the big engineering team, but with a limit token budget. And also in this area, the speed matters. So you don't want to put a lot of time in, building or maintaining your database or the infrastructure. Just pick the right infra for your agent, and the agent will handle the, other things for you. And the speed of the go-to-market is crucial. So yeah, I here is I code some, the comment from the cloud code team, which is, everyone should write code today because you don't actually write code. The coding agent write code, but everyone, you need to walk out of the boundary. Yeah, so uh, and TiDB is this kind of right infra you can rely on. So or your agent can relies on. So okay, let me close with my opening. And I think agentic engineering or agentic coding agent team, no matter what term you want to use, it is not a tool anymore. And today, you should treat your coding agent like a real engineering team and focus in the team, act like a team leader, focusing on the job that team leader should do. I think that's my takeaway here. And it is happening. And for me, the future is actually coming. And okay, the next part I will going to hand over this stage to my colleague Leah. He will show you what is the database should looks like in the area of agent. What is the agent friendly infra in the yeah. So thank you and welcome, Leah.
Thanks, Chad. So yeah, really nice talk. Yeah. I'm actually not spending like 1 billion per day. I'm spending kind of about a little bit of a million. So uh, away from you, but I'm trying to catch up. Hi, everyone. My name is Leah. So I'm a program manager from PingCAP. So today, like Ed said, right, so I'm going to talk a little bit about the TiDB as we believe it's a good database infrastructure for building your next generation of the AI applications or workload, right? Just to give some introduction for myself, I'm actually the everyone that I just talked about because I'm actually wearing both the PM and the designer hats. So, and I'm actually heavily using the agentic AI to code myself. So that's me. So I've been joining PingCAP for about like 2.5 years. So right now I'm a program manager from the PingCAP to focusing on the TiDB Cloud product. Yeah, so that's me. All right, so let's dive in. So I think at now have we've aligned at what's happening with agentic AI, right? So, but here I want to focus on what implies for the data layer. So I think the key shift, right? So for this era is like the database is no longer a passive repository, which just hosts like some static data, right? So agents are kind of a reading and writing constantly as they plan, act, reflect, and iterate. So this is kind of the today's shift of this kind of paradigm, right? So what that means, right? So that means the database needs to be act as a active like a substrate for automate agents, right? So it has to absorb the high frequency state updates, handle busty like coordination reads, and support evaluation and analytics so in the real time. So and the scale is different too, right? So I think it's right now it's not just like a more data volume. It's even like more like a metadata, more schemas, and a far more like isolated like clusters and contexts as agents and tenants kind of multiply this kind of effects, right? So let me just make that concrete to give you a few workload patterns that we've been observing again and again. So So the first pattern is the high frequency small writes. So think of the AI agents, right? So events, you have the tool calls, you have the state transitions, you have the memory updates, right? All kinds of stuff can becomes like those kind of part of the high frequency small writes. So the challenge is that an agent workload can actually generate thousands of these tiny writes, right? Or append of the writes per second. And I think it's usually mixed with the reads at the same time, just as the truth, right? So the requirements is like the predictive write latency under like a mixed workloads. So basically, you can't have like a low contention and background work suddenly spiking and disrupting the user-facing paths, right? Because that's exactly when your agents start to kind of feel unstable and start to kind of clog. So this is the first pattern we observe. Then, of course, we talk about writes, right? And there's a reads out there for sure, right? So this is kind of like a context retrieval, task queues, and the coordination lookups. It all contributes to this burstier reads facts. So think about agents tends to fan out, right? So what the fan out means, right? Like one user request can trigger like many parallel steps, and each step can even trigger more like reads and writes, right? So the requirement is kind of instant elasticity without data migration like overhead. So if like a scale takes minute or require like player with the data around, so actually you lose the moment and actually that will stall your like agent data pipelines. So this is kind of the read effects, the pattern we see. Now the third one. The third one is we call it parallel operation analytics, right? So this is kind of some addition on top of the normal reads and writes. So basically, every like a serious agent system that you are either building or you're going to build actually quickly adds this, the monitoring, traces, and evaluation matrix and rollups, all these kind of analytical functionalities, right? So just like I said, right, without like carefully monitoring how the agent work. So first of all, you don't have the level of confidential of that. And second is like, there's a way that, the agent is gonna just play off and you are kind of burning out all of your context, right? For instance, so you have to have some like monitoring system to, closely observe that what agent is playing, is behaving. So the challenge here is those analytics workloads needs to run alongside the transactions, right? So in the real time, because you are constantly measuring this, the quality, latency, total success rate, and the cost. So these are all like a separate, like the transactions stay away from your normal reads and writes that was generated by those agents. So the requirement here is like you should have a unified like mixture like a database system that can actually accept this kind of a ETL like workloads or analytic workloads, right? So if you need to copy the data into a separate analytic warehouse, so your truth, basically the data that you want to observe is always falling behind, right? So this is kind of like you have several separate systems. One is dedicated for your analytics, one is dedicated for your transaction. Then you're going to have to, first of all, establish this kind of synchronization. And second, and you're probably going to have some like risk to left your analytical data behind because you have to think it from the upstream of that. So that's the third pattern we see. So the pattern four. The pattern four is a massive multi-tenancy. What that means? So basically what it means is agent platform doesn't just serve one database. So actually they serve hundreds of thousands of isolated user contexts, like the users' workspaces, projects, agents, branches, and attempts. All those are becoming like isolated tenants that you need. The challenges here is that you cannot just treat each of these as like a heavyweight infrastructure, right? You need some lightweight to handle this. So the requirement is you have this kind of a lightweight, on the fly, elastic tenant isolation. So create and retire isolated environments quickly without operational overhead, exploding, right? So basically, like for each of those small tenants, you want to have our segregated space or tenants so that each agent can, leverage the data by the dedicated tenants and without, causing this kind of noisy neighbor issues to kind of pollute and impact on the rest of the tenants, right? And they also want this agent to kind of be created and destroyed quickly because, for instance, if you finish like one task, you probably no longer need all the context data or memory data for that particular agents, right? So you're gonna kind of just release this kind of the tenants quickly. So that's the pattern 4 that we observe in this agent database era. Now the last pattern we see, this is kind of straightforward. So the last pattern, what we call is the spaghetti stack, right? As the name says, so one database for transaction state, and then you're probably gonna have another vector database for doing embedding, and maybe a search engine for tests, plus your own like app logic, glue in between and stay somewhere else, right? So this kind of a mass of this wire that you see on the diagram creates like a fragmented state and operational like a drag, right? So you have like a double infrastructure, you have double observability platform that comes to you, you're gonna have like a double failure modes, right? So I think for agents, this kind of a latency, becomes like a killing effect for your real-time reasoning for sure. So I think here's a key thing, right? So you shouldn't need like a 5 database to kind of just to run one agent and glue them together. What we want is our like converged system, right? Then can kind of having all of them can hold the state, can kind of in charge of the search content, and also like run real-time analytics all together, right? Just one system for everything rather than like a separate and isolated system that you have to wire up by yourself. Yeah. So with these kind of requirements in mind, right? So let me kind of introducing back to our product and the company, right? So let me introduce TiDB and TiDBX, which is our cloud native architecture designed for this agentic era. So I think if you're new to TiDB, just to level set you some of the background. So TiDB is an open source, 100% open source software. We are kind of MySQL compatible. We are kind of distributed database, SQL database in nature. The mother company is called PingCAP. So TiDB is our product name. People are more familiar with TiDB, versus the PingCAP. That's for sure. No problem with that. You can just remember TiDB as our product. So we've been building this product and we've been building this database in this space for like almost like 10 years or even like 11 years right now, I think. And TiDB is kind of a widely adopted in production across many countries and industries, so you can see. So the reason this matters for agentic workloads is like the distributed database, right? The distributed SQL gives you our very good foundation for scale and strong consistency without giving up the SQL and the transactional guarantees. So this is the nature of what the TiDB is from the day zero. So now I think with this TiDB, we've been building in the past 10 years, right? So we actually recently announced our entirely refreshed new architecture. We call it TiDBX. So TiDBX is the next generation, cloud native architecture that makes these agents required practical at scale. So what TiDBX is, right? So TiDBX is an architecture name. It's built around a few outcomes that directly map to the agent workload patterns that we just introduced. Predictable latency and the workload. So that's we added, right? And the workload that we're scaling, durable and cost-efficient storage we provide as a source of the storage, and a massive multi-tenancy that we said, right? So every agent requires or deserves our dedicated tenant for that, and a future proof for foundational for all the AI capabilities. So in the next few slides, I'm going to kind of unpack how the architecture kind of deliver each of these kind of claims we are seeing here. So this is the simplified view of the TiDBX architecture. So at the top, right? So you have gateways and isolated SQL compute layer that can scale out. Then there's a shared cache layer for both row and column engines, right? So row engines for like transactional data and column engines for analytical data. So that's why TiDBX or TiDB, we also used to call us the HTAP, the hybrid transactional and analytical database. And underneath, the object storage is the shared storage layer, as you can see in the middle. And there's like a shared services like compaction, statistics, and the DDL handling sitting in the very bottom. So now I'll map this kind of architecture derived to the requirements that we just covered earlier, right? So we observe from the patterns and how to see how TiDBX can kind of satisfy or covering these patterns well. So the first one, the requirement one, is the predictable latency and the load, right? So this is very common. So I think for TiDB, we actually use workload isolation. So I think a heavy tasks like compaction, DDL, and analytics, right? These are actually the workloads that is not your business like queries, right? Your business queries is like a select and join, right, and read and write. So this is more like underlying like tasks, right? So basically DDL is something you're gonna kind of change your schema, and compaction and then analytics. These are kind of like the background, like the tasks that you're gonna run together with your normal like business query, right? But normally you kind of mix all these things all together to kind of share the resources. But TiDBX actually isolated this, right? So we're actually having isolated pools rather than competing with like agent-facing queries that I just mentioned about. I think for agent system, this is very crucial. So I think what that means is like your thinking loop can be derailed by the background work at the worst moment, right? Just like this diagram shows, it's kind of a computer segregation. We're not kind of a tap on each other's toe. And second is the workload aware auto scaling. So this is the second requirement. So basically, every the database, every like the DB infrastructure needs elasticity for busty concurrency, right? So I think with the TiDBX, so the way we are handling this is we are adding new nodes can kind of load data on demand from the object storage without traditional data migration. So this is how you get the fast scaling behavior when agents fan out, right? You want immediately, fan out your agents, if your workload has like, it's increasing, right? Then you, for instance, you have like more demand from the traffic. So immediately you have a spike of the workloads that requires you to immediately add the nodes for that, right? So this is how this workload aware auto scaling is about. And it also enables scale to zero, right? We're talking about scaled up, but scale down is also same important, right? So I think it also enables the scale to zero economics. So you pay only your active compute when your agent workload is active, right? Rather than paying a fixed footprint for all the time, right? So this actually saves the fundamental problem of lots of the database that you have. It's like you have to provision your resources ahead of time to cope with your maximum workload or spikes. So what that means is like most of the time, if your workload doesn't reach out to that spike for a few moments, you are kind of underutilizing or kind of wasting the resources you provision for that, right? So our workload aware auto scaling is the active way to kind of prevent this kind of symptom from happening. And then the requirement 3, right? So this is kind of talking about durability and the cost efficiency. So object storage, just like our most famous one is the S3, right? So object storage as the source of the truth gives you the durability, and it also opens up the tier storage across the hot, warm, and cold data. So this is important because first of all, the durability of the object storage is nothing to be comparable if you are saving the data on the local disk from a virtual machine, or you're using some like a blob storage like the EBS service for the AWS, right? So object storage is super durable. It can achieve durability about like 11 nines, which is nothing any kinds of storage service can be compared for that. So that ensures the super high durability. But at the same time, it's very, very cheap, right? It's dirty cheap. And then it gives the opportunity that you can save those kind of data which you're gonna infrequently access directly to the object storage, so that you don't need to kind of save all those kind of infrequent access data all the time on your hot data storage like block storage, and only for the time that you need to query that data. So we're gonna keep a slim portion of the cache layer still being hot, so that even that you require to occasionally read those data from the cold storage, that will also not impact your latency, because that portion of the data is also cached on the hot storage. So this is a mechanism we are introducing by with the object storage. And operationally, right? So you also want your backup to be kind of instant enough. So this is important if there is some catastrophic thing happens that you need to, revive your data back to the intact state, right? So that they don't become a planning bottleneck as the data grows, because this data will also be saved directly on the object storage instead of this pricing the block storage, right? So this architecture is built to make the snapshots fast, regardless of the total volume, because again, because of the price, right? So it's so cost efficient to save in the op storage. You don't too care much about the cost of that. Right, and there's a fourth requirement, if you remember, right? It's the massive like multi-tenancy. So I think in TiDBX, basically we make each cluster can be a lightweight compute allocation over shared storage. That means you can actually create and retile isolated like environments very quickly and swiftly, which fits like how agents behaves, like a fork, branch, and what kind of experiments your agent is kind of doing, right? So this design is actually proven by at very large cluster count and in the scale, which is exactly the direction agent platforms are handling. So we have covered the scalability and architecture. So now let's address the spaghetti stack problem, right? Data types and retrieval. So this is kind of our fundamental for the AI, right? So first of all, so I think this is the converge point, right? So one database that supports the key agentic data types. So you still need your transactional SQL and ACID guarantees for like a core application state, though this remains unchanged compared with the old era, right? Which you need any kinds of like transactional database to store that the traditional data types, right? But you will also need like the vector search for like a semantic similarity. So this is kind of a new, like right now, every database seems to be adding this kind of functionality, as well as like the full text search for like a keyword precision search, and ideally like a hybrid search mode to get the best context retrieval quality, which combine the both feature of them. So I think the big win here is like you have like fewer moving parts, less duplicated infrastructure, and fewer consistency gaps between the systems if you're choosing TiDB, because you will no longer need one database for vector, one database like Elasticsearch for the full text search, and some other database for the traditional transactional SQL, right? One TiDB can host and has support all these kind of multiple data types. Yeah, and also just want to share a little bit more about the hybrid search, right? So hybrid search combines the idea of the hybrid search here is it combines the key ranking, like the algorithm BM25 is a very typical widely used algorithm by the key text search, right? So and also you plus the semantic vector retrieval. So the keyword gives you precision when exact terms matter, right? So you're typing something, you want the exact result of that. But the vector search gives you like a record when users face things differently, right? So when you combine them, so basically you kind of reduce the retrieval errors significantly, which is one of the biggest contributors to to kind of narrow down or reduce the hallucination in the AI agent systems. So this is important. Like if you're building agent that people are kind of typing, searching something like a supporting system, right? So I think one of the key things is like you want to reduce the hallucination so that you can return back to the precise answers that the customer wants, right? So this is where this precision context via the hybrid search is about. And next, I'm going to touch just a little bit about the dev experience. So this is also important because I think lots of people are get used to using the SQL query, right, to kind of searching and kind of query the data. But more and more, like we see, they're like a full stack developers. They are more familiar with like high level languages like JavaScript, TypeScript, or like a Python's, right? So I think developers should be able to use the interface they prefer. So that's is our belief is. So if you are building an agent pipeline in Python, so you can integrate through the familiar vector store libraries that we hear. We actually provide our first party Python library. We call it TiDB. So which directly you can use it to leverage all of those the AI capabilities we have to kind of write application against the TiDB. But also you can still stick with the original the SQL query which you're familiar with to use this, right? That means the team can adopt TiDB incrementally, without complete rewrite their app and architecture. You're just using your familiar language to kind of develop and using the TiDB for. So I think the DevX is kind of plays a crucial part for make the life easier for the developers. Yeah, so I think when the other thing, right? So we see this kind of a spaghetti stack. So when you collapse the spaghetti stack into a unified engine, like this right hand shows, so you are basically lower both your operation complexity and the infrastructure cost, right? So this is obvious. So less glue code, fewer system to monitor, fewer data pipeline to maintain, and fewer failure modes during incident response. For agent products, we believe that operational simplicity is just not a nice to have. It often determines whether you can ship reliability and iterate fast and quickly for your AI like agent workloads. Right? So now I'm gonna give you some like introduction of the cloud offerings that is based on this TiDB X architecture that we're building. We have 4 layers. I'm not going to spend time to talk about that, but just to let you know, like if you just want to starting and play with something, we actually have a TiDB Cloud Starter, which is like a freemium tier. You can start with that. We provide a pretty generous like freemium allocation, the spaces and storage that you can pretty much rely on building your small agents, right? And progressively, when you are scaling your workload, you can choose like a higher layers like Essential, Premium, or even like a BOOC if you have some very restricted regulation requirements, right? All these, just want to mention, are built on top of the TiDB X architecture with the traits and the advantages we just mentioned before, right? Now let's ground this with a few custom proof at real agent platform, right? So this is our customer. Here's a large agent platform, customer running hundreds, thousands of isolated clusters where each tenant and project can branch agent execution environment on the fly. So this name might be familiar with you, Manus, right? Which is a company, they just got acquired by Matter, I guess was almost like 2 months ago. So actually Manus is kind of relying on the TiDB as the whole database infrastructure to empower their entire like agent platform, right? So that's has been proved on the Manus workloads. So We actually have a few more. This is not like a one-off. We actually seeing the same pattern across agent and AI applications, AI application platforms. So I think Manus has, like I said, right, it demonstrates the extreme multi-tenancy and the stateful iteration at scale. So right now, they've already created like over 1,600 kilo isolated clusters on the TiDB within a single like organization. Right? And also we have another platform like Diffie, which is another like a no-code generated AI platform, which is pretty popular among the community. They are also using the same infra to empower it, I think. Yeah, because we're short of time, I think this also comes to the end of my sharing before switching to the demo. But I'm not sure, Brian, do we still have a minute for the demo, or we can kind of leave
Yeah.
that later?
How much time are you thinking, Leah, for the demo?
Should be pretty quick. Should be like 3 to 4 minutes.
Yeah, we're pretty tight. Again, if you think you can get it in three, I think that's good. We have a couple questions here,
Okay,
but
let me answer the question probably.
yeah. So
Okay.
let's see. A couple that I found here. Again, well, looking at it now. So how does TiDBX address latency overall?
Okay, so I think the latency is first of all is about the data size you have, right?
Mhm.
So, but basically as a nature is like a TiDB is a distributed data system, right? So which basically for like a read and write, so we're gonna kind of spin out the nodes for handling like the workload that you have to guarantee the latency and the high availability, I think.
Got
So.
it. No, that sounds really good. How does TiDB's vector search compare to say dedicated vector databases like Pinecone or even Milvus?
Sure. Just to be honest, I think so. In terms of the feature set, I think the Python and the Melvis will still provide like a richer data set for that, right?
Yep.
So I think this is kind of the truth. But I think the advantage of the vector search in TiDB is just like I said, right? It's very well integrated into the rest of the database, right, with the transactional database. So
Mhm.
that if you just build up like a quick tool prototype, or if you are doesn't require the extreme like a flexibility of the vector search.
Mhm.
So you may want to compare with the easiness of the developer experience versus the richer the feature set from the dedicated vector search, like Python and Mavis.
Got it. No, thank you for that. That's super, super helpful. Looks like we have time for maybe one more question here. So another one that I have. So what's the migration path from say MySQL or Postgres to TiDB Cloud Essential? What does that look
Sure.
like? Yeah.
Sure. I think for MySQL workloads, it should be fairly straightforward because we are pretty much like 100% compatible with the MySQL. So
Mhm.
basically, you need very minimal effects or like kind of efforts to kind of migrate workloads. Postgres might be a little bit tricky. It really depends on how complex that you're using Progress, like how complex your schemas are, or what kind of like extensions that you're using. So I
Mhm.
think right now there are still like a migration, efforts for if you're migrating from Postgres. But just like ASA, right? So we are actually working on our Postgres compatible layer. So once that's coming, so we believe that we're gonna dramatically reduce the migration efforts if you're coming from Postgres domain.
Awesome. No, thank you for that. That's super helpful. And yeah, it looks like now, again, we're kind of at time, for everyone. Again, I hope everyone really enjoyed this presentation. Again, it was a great content, kind of from beginning to end. For all those still here, we will be sure to make a recording available to everyone who registered for the webinar in the coming days. So stay tuned for your inbox. You'll definitely have something there. And as Leah mentioned, TiDB Cloud Essential is going to be generally available on March 31st. So you can try our free starter tier now and sign up for that essential public preview right now at tidb.io. So with that, thank you all for joining us today, and we will talk to you again soon. Have a great rest of your day.
Thank you so much. Take care.
Take care.
Bye.